Good afternoon, everybody. My name is Eric with Bobcat Cam. I'm the demo technician here with Bobcat, and what that entails is doing demonstrations of the software program for potential customers, and I also am part of tech support, so answer any questions or concerns from customers of ours. And I have been doing the live events recently as well, helping you guys out with certain tips and tricks on different modules that we have here in Bobcat, version 35 that is now out. We also have plugins for different CAD software programs we'll be looking at today as well. So we have our standalone version with our CAD software package of version 35 to be able to design in. And then we also have the programming side of things in our version 35 as well to program for milling machines, lathes, also wire EDM machines. We're also able to program for laser, plasma, and water jet machines as well. When it comes to lathes, we also support lathes with live tooling. We have a mill turn package also. That's all in our version 35. And then we have all of that programming functionality in our plugin versions as well for other CAD software programs, including SolidWorks and also including Rhino now. So we have our 10th iteration. So we're on V10, BobCam for SolidWorks. And then we're on our third iteration, version 3, BobCam for Rhino, or for Rhinoceros. We're a partner for them for their CAD system. We're also a gold partner with SolidWorks as well for their CAD system. So today we'll be looking at the advanced drilling options that we have now. We now have a hole recognition option to be able to define a solid model in our CAM system and let the CAM system do the work for us to recognize all of the different hole sizes that we've got with this part file here and sort all of the operations out by hole size. Let the software know if we're going to be doing a tapping operation along with it or counterbore operation along with it, and also if there's a chamfer among the holes, if we're going to be doing the chamfering as well. So we're going to wait for maybe 1 or 2 more minutes to see if anyone else will be joining us live today. I'll just reintroduce myself here. My name is Eric. I am the demo tech here at Bobcat Cam. So I'm doing demonstrations of the software program for potential customers and also for customers that are interested in upgrading to a new package. Any new modules they want to check out, I can demo that for them. I'm also part of tech support, so any questions or concerns that our customers have with a software program, you can call or email in, and we can answer those questions for you as well. I answer those questions for the customers of ours with Bobcat also. Whether it be with designing in our CAD package, programming in our CAM side of things in our standalone version, and also with the other 2 versions that we have, BobCam for SolidWorks and BobCam for Rhino. So probably in about 60 more seconds, I'll wait and then get started with the hole recognition options that we're going to be going over today. We're going to be going over the options in our standalone version as well as our plugins as well. And while we wait here, I'm going to type in the chats the contact information for you guys to have in case you have any comments or concerns, any questions you guys have. Please let us know with tech support with your software program if you have any questions at all there. All right, so I just added in the chat there our tech support phone number and our email address. And you can contact us at 727-489-0003 for any tech support questions. You can also get to our receptionist and get to your account manager if you have any questions about licensing information. And you can also contact us at support@bobcad.com for an email address. Any questions you guys have, you want to send in a part file that you may have an issue with, just let us know, and you can attach that in an email to us as well. All right, and we'll get started here in the live event today, taking a look at version 35 first, and then the plugins for SOLIDWORKS and Rhino. We'll be looking at mainly the hole recognition option today here. It's a newer option. I believe it started in version 33 or 34, but it's a newer option here that is very useful if you're going to be drilling many different types of holes with a solid model. Now, what we used to have to do, and we're actually starting on this side of the part here, what we used to have to do is, once creating the milling job, we would have to go into the mill drill hole and then select the geometry, maybe select the specific sizes of one type of hole first, create a feature for that, and then keep going down the line. You would have one feature in here for drilling holes of one size, and then you'd have to go back in, mill drill hole, do the size of that feature as well. Or what you would have to do if you selected all of the holes of a certain size, it gets pretty convoluted in here once you go into Mill Hole Wizard, select your geometry. Let's see if I've got the wireframe here. Yep. So if I select the wireframe, now it'll group all of them together, and you have all of them here in the feature. It separated out as different features of different hole sizes. You can't see which ones they are. Maybe you can get to the hole sizes here. No, you don't. You don't see a. You don't see an example of it here in the features and all of, I mean, you've got the whole size, but you don't know which ones are which here. So yeah, a little difficult to find what you're looking for if you're doing it that way. But what's very helpful here is being able to, I'm going to delete this feature. You know what, maybe we'll start from the beginning with a milling job and then look at the hole recognition. So we'll start by going to the top, going to CAM, and starting a new job. We can define it as a milling job type. As I went over before, we also support turning for lathes, mill turn for lathes with live tooling, wire EDM machines, and under the milling job type, you can see we also support plasma machines. We support laser, plasma, and water jet machines as well. But today we're going over the milling, so we'll select our Bobcad 3-axis mill machine here. Go into our stock wizard where we can define our workpiece as our finished 3D model, so we can see that in our simulation. We can define the stock that we're starting with, whether it's rectangular like we have here. If it's a cylindrical shape, this will be a bounding box around the outer geometry there, or the bounding cylinder, which will go outside of the whole 3D model, going around the corners there to give us that kind of shape for a cylinder. Extrude from wireframe. Select an existing solid model or STL model or a revolved shape here for our stock. We're just going to be very basic here. Select our rectangle piece of stock and calculate the stock there. And then our last page, once we go forward again, will be our machine setup. This is where we're defining our work offset at. So if it's not at the center of the stock, if we're jogging the tool over to the bottom left corner of the stock, like it normally is right here for most people, for most times, we can click on origin right here to highlight that, and then click on our bottom left corner of the stock here. So now that will be our work offset for G54. And in the G code, XYZ0 will be in relation to this point with our G54 here. Then I'll click OK. We can highlight the machine setup again, see where that is in the cam tree that we have here. Then we can right click on machine setup 1. And just like I showed you before, we do have the drilling and tapping options here, counterbore tap options here. But instead of going through that process of doing all the different hole sizes, the third option down here is hole recognition. So now we can click on that. We can highlight our selected geometry. If there's different solid models here, we can select all of them, or just select the one solid here and click OK. And now it will pick up all of the different hole sizes. I can highlight each one and it'll highlight with a different color what the 291 diameter holes are. Highlight this one, it'll show us 1 inch, 102 diameter, 629 or 630 it looks like, 315, 366. So all these different hole sizes, and I can also rotate around while I'm in here to make sure that there's not going to be any like counterbore operations, or I mean like with this one it's not a through hole, so I want to make sure to let the software know that we're not doing a through hole with these within the feature. And then if I flip it over, I can check to see if there's going to be any like counterbore operations on the other side if I needed to flip it over for that. So no, everything looks good here. If I scroll up or down, again, highlight each hole, and then there's a couple check boxes here, and then a drop down here. So I actually spoke too soon with defining the different hole types with a blind hole. That was already checked here with this checkbox that it is a blind hole and not a through hole for these here. And then what else? So if there's a chamfer along any of the holes, we would check that box, but usually it would already be checked off. If I didn't want to do it, I would just uncheck it. Then there would be the different feature types. So all of these are going to be drilling operations. Maybe I could add a tapping or a counterbore or a counterbore tapped hole in some of these hole sizes. I'll do a tapping for one of them here. These aren't really standard sizes for the diameters. I'll do the one that's at 630 here. So these 4 here, I'll do a tapping operation, for example. Do a tapped hole. And then I'll hit compute. Once I hit compute, all 7 of these features, right, 7, 1, 2, 3, 4, 5, 6, 7 features will be computed automatically. You can see all of the toolpath for all the different hole types here. I'm going to go to my, let's see, this was the blind hole, and see how maybe I can back plot this one, see how far it's going down. First, I'm going to blank out the stock because that's kind of annoying there. I'll hit blank here to the left, this eyeball icon, to blank out the stock. Then I'll go to features that have the blind hole, and then I'm going to backplot it, see if it's got the right depth. So if I expand the feature, I'm going to go down to the drill operation, right click on it, and go to backplot. So we can right click on any operation here in the cam tree, go to backplot, and that way we can see a really good representation of the tool and the tool path that it's going to follow. And then if I get to a certain step like this one here, I want to make sure it's getting to the right depth here. I'm not sure if it's at the exact location I want. I think the tip of the tool is getting to the depth, but not all the way down. So I can adjust that as needed. But right now I'm looking at the sleeves of the holes, the surface is there, by making the solid transparent and then making it back into a solid. That's a short key on the keyboard, T for transparent, S for solid, so it'll hide the solid or show it again, and then W for wireframe. Maybe if it's transparent, and then you've got wireframe to show for that as well. So S, W, and T. S for solid, W for wireframe, S for solid, and T for transparent for me to see the total depth and make sure it's getting down to the right size there. Looks like I need to adjust it a little bit. Looks like just the tool tip is getting down to there. Maybe some kind of safety feature there, but I can go back into the feature and adjust those depths. But everything else should be good since they're all through holes. All right, so the next step here to look at for the hole recognition is you can see that, let's see, I mean, for most of these features, they all have a center drill and a drill operation. And then for this one, it has the tapping operation. It actually has a chamfer, so center drill, chamfer drill, and then a tapping operation. So all of these features, I mean, I'm telling it as a chamfer drill first and then a tapping operation. Maybe if there isn't a chamfer there, then I wouldn't want it maybe, but we can set all of those settings in the knowledge base here in Bobcat. And that is at the top under CAM. You can click on this icon of 3 books, it looks like, called Knowledge Base. You'll click on that icon. And this is called the Knowledge Base Manager, where you can set different, what they call templates, and you can set rules in each of these windows here, whether it's for drilling, for counterbore, for tapping, or for counterbore tapped. For example, tapped, I'm sure we'll have something along the lines of drilling, chamfer, and then tapping here. Let's see, chamfer drill. Yeah, so with this one, we've got the chamfer rule group. But this one, it says if it has a chamfer, then it'll do a chamfer drill. If it's less, okay, so if it has a chamfer and the chamfer diameter is less than 625, less than 5/8, then it'll do a chamfer drill operation. If it has a chamfer and the chamfer diameter is more than 5/8, it'll do a chamfer mill operation. So that's where we can set templates here based on the hole sizes and what type of operations we want to do for each of these hole sizes. Then if we go down to the next step, has a chamfer false. So if it doesn't have a chamfer, then it'll do a chamfer drill for the tapping operations. So what this is saying is that even if it doesn't have a chamfer with the geometry selected, it'll still do a chamfer drill operation before any tapping operation. So if I just deleted that one, then it wouldn't have that chamfer drill operation before the tapping operation here. So again, that's how we can set up a lot of default settings with the drilling operations so that we can have everything dialed in here so we don't have to make any adjustments when we're doing the different drilling operations. Everything's going to be saved by default. Alrighty, and then so after that, what else we got? We've got the through holes, so we can make sure that we're doing as going through the geometry here for each one. And it's doing a pecking operation here down through the hole there. And Why is it doing a pecking operation? Because in the knowledge base, you go to cam, go to knowledge base, go to the drill section, and I'll go down a little bit. The first one here is it's always going to do a center drill and drill. If I don't want it to do a center drill or spot drill here, I can just select just the drill option. Or actually, there is no drill option. I would just delete this so that there wouldn't be a center drill in there by default. And so we've got our chamfer drill and chamfer mill options like we said before. We've got our pecking options. So we can set a certain formula here to save as a certain default setting. And for this one, if the depth of the hole is less than 3 times the diameter, it'll do a single depth. Here we get out our math calculations here. We've got the depth is greater than or equal to 3 times the diameter of the hole, then it will do a pecking operation. So it'll either do a single depth or pecking, depending on the depth of the hole. So that's why this one has a peck drill option. And then other than that, yeah, it's just going to go through the center drill and drill operations for each of these here. What else we got? We can simulate next and take a look at that. So we'll go to the top, go to start simulation. And while I'm going through the live event here today, please let me know if you guys have any questions or comments in the comment section here. Be able to answer any questions that you guys have moving forward here. So here at the top, we've got our estimated cycle time. It says it will take 3 hours and 16 minutes, which seems like a huge amount of time just for some drilling operations. And that's based on the feed rate. So I'd want to go back into the features and change the feed rates, and I can save those feed rates as the default setting as well to keep the cycle time down each time. And right now we also have the stock showing and the workpiece showing. I don't want to see the workpiece in here. I want to see the stock being removed. So I'll go to the top and hide the workpiece by clicking on that. And then I'll slow down the simulation run speed and hit run. And it'll do the center drill first for all of these guys. Limit tool changes, so we'll just do the center drill first, and then we'll do the different hole sizes next. I want to get rid of the tool path showing so that I can see the holes better, so I'll just click on that icon to hide the tool path. It did the chamfer there, and then it did the tapping operation. Zoom in, see the, is that one? Or I can restart and see it being done there again. But yeah, once all the different hole sizes are done here, I'll pause, I'll restart it. I'll skip a couple operations by hitting next stop so I can skip all of the center drill operations here. And then get to the drilling here. And so here is the hole. Here are the holes that are going to be chamfered after this. And then a tapping operation. There we go. So there's the chamfer on these 4 holes. You can see the chamfer drill. And then the tapping operation. And then the drilling of all the other holes to speed up the runtime there, speed up the process. So once all of the different holes are drilled, we have, oh yeah, we forgot about the blind holes here. That's one setting that I just remembered about. We'll go back to the blind holes. We'll go to the depth. And I'm not sure what the total depth is, so I'm just going to go to my feature. I can pick the top of the holes. which that's going to be 0. And then I'll pick the bottom, which presumably is not going to be 944 or 945 here. So I'll pick bottom, I'll zoom in, and I'll pick the edge of the hole here. And that actually is the right depth, but if we go to here, overall depth, maybe I'll have to select the overall depth. Let's see. It's actually looking better. Yeah, it looks like it's going down to the right size now. Double check with the back plot here. And make it transparent to see the total depth we're going down to. Yep, that looks good. It looks like it's going right to the correct depth there for each one of those holes. So yeah, just a minor adjustment there for that setting. Also with the feed rate, right now it's going at 0.37 inches per minute for this drilling operation at least. And it's using the system feeds and speeds. So the reason for that is we go into the material type here. So if I drop down, expand the stock, we have the material type that I can right click and edit. And this is the material type, or material library with feeds and speeds in here depending on the material type and the feeds and speeds for each material type. So whether we're machining from carbon steel or aluminum or different types of plastic, we have different feeds and speeds set up in here. So if I change from carbon steel to aluminum, for example, let me go in, I'm sure the feed rate will be a little different, a little better of a feed rate there, 5 inches per minute rather than 30 thousandths. This one's 19 inches per minute. So if we take a look at the simulation, should update all the feed rates for all the drilling operations there. Cut down on the cycle time. When it was 3 hours, now it's 16 and a half minutes. Sounds a bit better of a run time there. And we can run through it again real quick. Center drill and the drilling operations, chamfer and tapping with those holes that I selected. All right, no crashes, nothing bad there. Got the estimated cycle time. We've got all the holes drilled to size. We can close out of the simulation here. And then from there, we just hit post at the top. So next to simulation buttons, we have post. It'll generate the G-code on the right-hand side. Right now we're using our BC3X mill, so that is our Bobcat 3-axis milling machine and post processor, and that will format the G-code for our Bobcat milling machine, which is a Fanuc-based post processor. You can see here generic Fanuc, and you can see the formatting for the G-code here is for Fanuc post processor. Say if you're using a different machine here, we can double click on the machine and change it from Bobcat to Haas, for example. Or the generic Haas posts will be brought in, or we can post and it'll be formatted for a Haas machine. A little different formatting there. And if there's any post processor in here, if you don't have the post processor that you need specifically for your machine, you can go to bobcatsupport.com and you can download a post processor there. You just run the exe file and it will load into Bobcat for you here, where you can select it. And if we don't have the specific post processor that you need, or if there are any modifications you need for your specific machine, you can send us the post processor that you're using, and also send us a sample program that works on your machine. Send us a list of G&M codes and their functions, and any CAN cycles that you're using, and we'll be able to do the post modification for you. That's included with support, from what I understand. But if you're not current with support, contact our Bobcat team, contact your account manager to see what our policy is with what we've got here with post processors. I know that is included with support, but if there's anything involved with it, I know with mill turn post processors, it might come at an extra fee, at an extra charge. Um, but yeah, if you contact your account manager, we can see uh, what we need to get done to modify the post processor for you. And so I think that's about it with the hole recognition in V35. We'll take a look at the other two software programs that we support with CAM, with programming, with SolidWorks, and with uh, Rhino. Please let me know if you guys have any questions with it. Anything else in the software programs I can go over today as well, since it's kind of a light topic, just going over the hole recognition option today. All right, and we'll get to, let's see if I can switch it over here in Vimeo. There's a new option to change how I'm sharing. So share screen, and I'll get to SolidWorks next. So this is going to be BobCam for SolidWorks. This is V10 BobCam for SolidWorks. And for you guys just joining with us, we were just in version 35. So if you want to go back and look at the hole recognition in V35, it's going to be the same workflow here. So you could also follow along with us. And here with this part file, I'm going to delete the milling job that I have right now. And we're going to be focusing on, oops, SolidWorks is stalling on me. Let me try to close out of it and reopen here. Or maybe I could start on Rhino while that's reopening. It tends to happen a lot with SolidWorks when you have it open for such a long time and start to work on it. Sometimes it'll crash on you like that, unfortunately. So let us go right to Rhino first. And from here, we can start a new job. So I've got that part file in Rhino, just like I just had in SolidWorks. And we'll start a new job. So you can open in Rhino, you open the solid model, and then you can open BobCam by going to the top, going to BobCam, show BobCam. It will open up the cam tree here, where I can right click, go to a new job, define it as milling here, and start right into my stock wizard. And just like we saw before in the standalone version, we select our geometry for our workpiece. So we could see that in simulation, our finished 3D model. Our next page is our stock definition page, where we can define the stock, whether it's rectangular or cylindrical or any other shape for our initial stock that we're starting with. If we want to extrude it from wireframe, select an existing solid model or STL model, or revolve a surface around to create a stock model here. And so we're just going to be using rectangular stock and drilling along a square shape like this. So our last page here is our machine setup. This is where we're defining our machine 0. So if I'm touching off at the bottom left corner here, like I just clicked on, I would first click on the origin box here to highlight that, and then click on the point, and that would be my new G54 work offset location. And in the G code XYZ0 will be all referenced here at this location. I'm touching the tool off at the center of the stock, for example. Click on that point. Click anywhere there for my G54 location. So I'll click OK, and I can highlight machine setup at any time to see my G54 work offset location. I can right click on it, and then here's where we have our drilling operations at. You can see mill drill hole, mill tap hole, mill counterbore hole, mill counterbore tap hole. I don't think I have wireframe in here, but what I did in version 35, we'll go to the same model here. If I have the wireframe, which I can pick up really easily here in Bobcat, under Create 2D and Extract Edges. So with my wireframe here, if I am in the software, and I am going to mill drill hole and selecting my geometry as all of the holes here, it breaks it up into different features, but I'm not able to really highlight any of them and see an example of the holes. When I go to the next page, it will bring them in, separate them out into different features. But again, I'm not really able. Well, here you go. When you highlight the group of holes, at least you can see what you've got. Maybe you could kind of move the window over and see what you're trying to look for there. But to make things a lot easier, then go through that and go through all the features here and set up the sequence of each feature, the sequence of operations here. We'll go to Rhino again. And we can right click on the machine setup and go to hole recognition, select my solid model, and click OK. Right before I click OK, though, we'll take a look at all of the other settings in the hole recognition option. We can ignore the Z location of all the holes. We can use as top, so all of the top areas will be understood and used for the top of the hole. So if there was already like a pocket going down to this hole, it'll start at the certain location we need to, and also use as bottom. So we can set all the specific depths that we need here. And then our other options here are minimum hole diameter. So as long as it's 10 thousandths or larger set up by default, we can it'll pick up those holes. Up to 10-inch diameter. So we're saying if it's larger than 10 inches, then it's probably not a hole. We'll probably be pocketing that out. And then minimum sweep angle. So the arc has to be at least 270 degrees. So it has to be 3/4 of a hole at least for it to be detected here. And the tolerance of 5 thousandths. So all of these settings are set up by default. I believe you can change the template here to change those settings. You can select whole bodies, or you can select wireframe, it looks like. And yeah, those are the options in the hole recognition. But all of these settings are pretty basic by default and pretty standard, where if it's smaller than a 10 thou diameter hole, you're probably not going to be drilling it. If it's larger than 10 inches, or I guess you could say, it's probably not a hole. And then with the maximum hole diameter of 10 inches, again, it's probably too large to be a hole. It's probably a pocket that the software is picking up. So then we hit OK, and we've got all the different holes highlighted here. And here in the hole recognition page, we can highlight each one, just clicking on each feature, and it'll show us which hole this one is, 1.25 inches. These are the 1/4-inch holes, and this is the 1/375. That's a 3/8 inch hole. And we can highlight each one. We can see the checkbox for the chamfer is already checked. So if I don't want to do the chamfer, I can uncheck that box. Or if I wanted to do a chamfer on any of the other two groups of holes, I can do that here by checking the box. All of these are through holes. So none of these are going to be checked for a blind hole, but if I only wanted to go down to a certain depth, I can check that box. and till at a certain depth. And then for drilling, we can tell the software whether we're only doing drilling with the hole option, tap hole, counterbore, or counterbore tap hole options here. So if I wanted to do a tapping operation with the 1/4-inch ones, for example, I'll drop that down and select tap hole and then hit compute. Then we've got the 3 features already set up here in the cam tree automatically. We've got the 1/4-inch hole to start with, and the 1.25 inch, and then the 4 1/4-inch holes, and then the one at 375. Now let's look at the chamfer first. So we did the center drill, the drill, and then the chamfer mill operation. So I'm going to backplot that and see how that's being done. I can expand a feature, and then I can right-click on an operation and backplot any operation here. So we took a look at there was a chamfer drill operation in the last part file that we looked at. This one's a chamfer mill operation, where it goes around the circle here, goes around the chamfer of the hole, or the diameter of the hole there, and then leads out with a circular lead in and lead out there. And we can set all of those settings, whether we wanted this to be a chamfer drill or a chamfer mill, and whether we wanted to do a spot drill for each of the holes first. We can do that in the knowledge base, and that is found here on in BobCam for Rhino. It's the same icon in BobCAD version 35, and also in BobCam for SolidWorks. It's icon of three books there, and then in BobCAD, we go back to that. It's under Cam, and then knowledge base right here. So we'll go to knowledge base, and it'll open up this window. I can maximize it here, and we can set up different rules here. I'm not sure if you're able to see that or not. Let me know if you can see the window we've got for the. Once you click on knowledge base, you can tell the software, like for example here, the chamfer. If the hole has a chamfer and is less than 625, it'll do a chamfer drill by default. And if the chamfer is larger than 625, it'll do a chamfer mill by default. So those kinds of settings, depending on the hole sizes, we have templates or default settings for different hole parameters. Makes things a lot easier than having to go in, change it from a chamfer drill to a chamfer mill, for example, set up the certain tool, set up the compensation, and all of the different settings here. Everything, we already got a blended, which is basically a circular lead in and lead out for us by default that we've saved as a default there. And so we'll take a look at the simulation for this by right-clicking on the milling job, going to simulation. We've got the center drill operation first, and then the very large hole next, 1.25 inch hole, and then I think it's the 1/4 inch holes next. They're sorted a certain way here in the move list. It says drill and then chamfer mill, and then it'll get to drill, pecking down into the material for that one. And we can set up the specific. What was that last one? Looks like the tool wasn't long enough for that last operation there. What was that? It wasn't the pecking. Was that the tapping? Oh yeah, that was the tapping. Interesting. So it looks like that default tapping tool wasn't long enough. So we'll close out, go to that feature there. But yeah, it's a great thing for simulation, being able to take a look at what's going on there, our system tool here, we can modify by unchecking system tool, go to modify tool right here in the tool page. The flute length is only 2 inches, and I think that is the total depth, the total thickness of the stock. So we'll make this 2.5 inches. We compute that and then simulate it again. Invalid flute length for that tool that I made. Okay. Doesn't like that tapping tool that I made. Maybe I'll just go into the tool crib or the tool library and see if there's anything I can have as a longer flute length. Spiral taps, no. Yeah, all of them are a specific flute length. Oh, overall length? Okay, so maybe with it being the quarter 20, I'll go back to the system tool here. And I'll change it back. Well, oh, wait. No, I think the only thing is that the flute length, the overall length isn't long enough. So let's change that to 2.6 along with the protrusion length there. That should be good. Okay. That looks good. We've got the simulation here. It says the estimated cycle time will take about 25 minutes and 9 seconds. Seems like a pretty long time for a few spot drills and tapping operation. Spot drill, and tapping. It likes the chamfer and tapping with a 1/4 inch 20 holes there as well. But I want to cut down on the cycle time. And to do that, the easiest way is, since all of these tools, they're all set up with the system feeds and speeds at about 1 inch per minute plunge feed rate with a spot drill, for example. The system feeds and speeds are based on the material type here under the stock. So if I expand the stock under the cam tree, we have the material type as carbon steel. I can right click on that and edit, and it opens our material library. So whether machining from carbon steel, aluminum, different types of plastic, we have feeds and speeds for each material type. And I just change it from steel to aluminum. And now that center drill from 1 inch per minute, it's now at 12 3/4 inches per minute plunge feed rate. So rather than it machining at 25 minutes for the total cycle time, we'll go back to simulation. And now it says that it is going to take 2 minutes rather than 25, based on steel versus stock, based on steel versus aluminum that we're machining from. So once we are done with the simulation and everything looks good, we can right click on the milling job, go to post. It'll generate the G code here in the posting window, where I can right click on it and save it, put it onto a flash drive, and send it over to the controller from there. If you're a little more old school, using an RS-232 communication cable, you can right click on the posting window and go to NC Editor. It'll open the G code in the NC Editor that we have, where you can modify the G code. Everything's color coded here. Our comments are in green. XYZ moves are different colors, so we can easily find what we're looking for. Then we can go to the top and go to Tools. Go to Start DNC Transfer, where I can set my port number, set the baud rate, and set all the other settings for the machine to send or receive from the machine. Another tab over, we've got character delay and line delay for drip feeding. So all the necessary options for an RS-232 cable, like a 9-pin connection or whatever you guys have there. I know we've had some guys recently in the past using cables from USB to a 9-pin connection. We always recommend, if there's any drivers that need to be installed, you'll have to run those and make sure everything is running specific for your machine and for that cable you're using. So that's about it with the plugin for Rhino. We'll take a look at the plugin for SolidWorks next. I'll just close out of Rhino. See if I can share SolidWorks. There we go. All right, so SolidWorks is up and going. Remember how to revolve this around, a little different than Rhino here. So, but it's going to be the same workflow as Rhino in the standalone version. And just like in Rhino, you've got a cam tree out here. You've got your feature tree and all those other trees in SolidWorks. You just tab over to the cam tree that loads in with BobCam for SolidWorks V10 that is out now. And we'll start with a new milling job here. So to do that, we right click on cam defaults and go to new job. It'll be milling. Of course, just like the other versions of BobCAD, we have turning, mill turn, wire EDM, and milling. We have routers, 3-axis, 4-axis, 5-axis milling machines, laser, plasma, water jet machines. We'll go to mill, 3-axis mill, and go to the next page where we're defining our workpiece. We are defining the stock that we're starting with. Oops. So just like before, we are setting it, whether it's rectangular here, cylindrical, from wireframe, solid model, STL model, revolve surface. Then our next page is our machine setup. So again, setting our work offset, highlighting origin, clicking on a point. This is basically going to be the same workflow as setting up a coordinate system in SolidWorks. You could also pick from an existing coordinate system in SolidWorks. And then hit OK. And then we would right-click on the machine setup in the cam tree. And just like we were shown before, we've got the drilling, tapping, counterbore options. Instead of doing that whole process, we just go to hole recognition, select the solid model, highlight each one, and see what we've got there. That one is very bright for the examples there. And then we can set up whether we're doing the chamfer and all the other settings there, and hit compute. And then simulate. Make this screen larger here to see the simulation. Where it'll do the center drill first, the chamfer mill, the drill first of the 1.25 inch, and then the chamfer drill. Drilling all the 1/4 inch, drilling the 3/8 inch hole, doing that chamfer mill there as well there. Yeah, and I think that's about it with SolidWorks. Again, the same workflow as the plugin for Rhino, and also the same as the standalone version for BobCAD. Now, very similar to Rhino, we right-click on the milling job and hit Post. Again, it'll generate the G-code in the posting window where we can either save it or edit it. Save it and put it onto a flash drive. So yeah, that's the basic gist of the hole recognition page. I'll go back to BobCAD real quick. Kind of give you a one more brief overview of it. So we go through getting the 3D model, creating the milling job by defining our stock, defining our machine setup. We want it here at the bottom left corner or maybe at the top left corner, depending on where you need your work offset at, how the vise is laid out, things like that. Got our machine setup where we right click and go to hole recognition. Rather than going to the drilling and tapping operations and sorting all the different holes and different features, the hole recognition, when selecting the solid model, will give you all the different hole sizes, whether it's a chamfer or not, whether you're doing the tapping or counterbore operations, you can set that here and hit compute. And you've got all of the different settings that are saved under the knowledge base window here to set up all the different rules depending on the pecking for each hole size preferences, the chamfer drill or chamfer mill preferences for your specific holes that you're chamfering, and specific tapping preferences, settings there that you can save for next time. So rather than having to get the wireframe of this solid model and create features independently of each other for each hole size, you can go right to the hole recognition option now, select the solid model, and it will sort all the hole sizes for you, and also give you the feeds and speeds that you need for the certain material type that you're using here with your material library. And in your material library, you can also add a group if you don't see it here that you need, and add a material type, name it, and set your custom feeds and speeds that you need for each material type. And these are pretty conservative numbers, but we always recommend that our customers contact your tooling manufacturer just to make sure that all the feeds and speeds are dialed in for your specific tool. We don't want you guys, excuse me, we don't want you guys breaking any tools there, and we want you to keep the life of the tool as long as you possibly can, and at the same time making sure that you're making chips and getting everything dialed in to the right machining times that you need, and going on your way there. So we'll go out of the material library, and I guess we'll just take a look at the simulation one more time. And this whole recognition option is just 1 hour today, so it'll give you your time back after the simulation. I'll run it pretty slow so that I can go to my other screen here. And we're just going to be reviewing what we've got next week and everything following there. You can find our schedule for our live events at bobcatsupport.com. This is where you can go and find post processors to download. You can find technical support, request a ticket there. You can go to the knowledge base articles that we have on our support portal. They are very helpful in case you have anything that you have questions about, or any issues that you have. Maybe it has already happened in the past with tech support, and you can get a very easy answer there and straightforward for you guys. That we any issues that we've logged before, we give you knowledge base articles to help you along with that, instead of having to wait a few hours for tech support to get to you in the queue. You can search for it yourself if you'd like. But then you can also go to training. This is where you can find the schedule and view the live events, and also the recorded virtual events that we're going over today and previously. And let's see. So next week we have 2-axis wire EDM. And then the week after that, so next week is May 31st. And then the first week of June, that'll be after the wire EDM on May 31st. The first week of June, June 7th, is going to be on, let me see here, It's going to be on advanced 4-axis milling. So it's going to be going over a lot of the new 4-axis stuff that we have. We've got with 4-axis, we've got deburring is a new option for 3, 4, and 5-axis premium tool paths. We've got an advanced rough and an advanced finish in 4-axis around a rotary that can be really helpful, and then some other settings for indexing as well. So yeah, we just kind of went through the V35 advanced holes here again with this part file. You saw how easy it was just right-clicking on the milling job and going to hole recognition, selecting the solid model, and getting all the different features that we need for each hole type, and hitting compute, simulating, and posting the code from there. Saves you a lot more time than you would have done in the past of getting the wireframe, getting the total depths, getting the hole sizes, and separating out the features for yourself and setting all of those custom settings that you need every single time. Everything's going to be saved for you for next time. So thank you guys for joining us today with the hole recognition option, newer option that we've got in our V35 that we have here, our standalone version of Bobcat. And we also went over the plugins that we have now, Bobcam for SolidWorks V10 and Bobcam for Rhino V3. And if you guys have any questions or comments, please let me know in the comment section. I can answer anything that you guys have. And if you have any questions moving forward, please let us know at the phone number and the email address that I have in the comment section. Our phone number is 727-489-0003. And our email address is support@bobcat.com. Thank you guys for viewing the live event today, and hope to see you next week. We're going to be going over the 2-axis wire EDM programming, and then the week after will be advanced 4-axis milling for Bobcat, and for our plugins as well. We'll be taking a look at kind of looking at the workflow of all 3 of our products that we now have to offer for each week. And thank you all for viewing the live event today again, and hope you guys have a great rest of your day. Thank you very much.